All right, I think it's 3 o'clock, so we'll go ahead and get started. How's everyone doing today? Is this like the best Boston weather of the year, or? All right, I'm from San Francisco. This is what it's like every day out there. No, this is actually my favorite time to visit Boston, is always in May. Miss the snowstorm and here. I like to get to know a little bit of who I'm talking to. So I'll start with easy questions. How many people are building robots here? Okay, pretty good. All right, how many folks are on the engineering side of things? Okay, so almost everyone, good. And does anybody here know fictive already? Cool, a few, so not many. Paula, who works with us, says she does. So really excited to talk to you a little bit today. I really want this to be informal. Please raise your hand halfway through talk. I'd rather it be a discussion rather than me presenting the whole time. We'll try to get through the content and talking about with some Q&A at the end. So if you have questions, you can save it for the end. The goal for today is to talk a little bit about how do we shorten development cycles, specifically in new product development, so that you can get to market sooner and reducing risk in all the systems that you build. We're going to talk a lot about the mechanical aspect of robots, so plastics, metals, infrastructures, tolerance, that aspect. It'll touch on electronics, touch on software. I think the principles are similar, but for today, we're really going to focus on new product development and how you can speed up development cycles. Sound good? Cool. So a little bit about me, so you have it. I'm Dave Evans. Dave Evans, co-founder and CEO here at Fictive. I'm a mechanical engineer from Stanford, cut my teeth at Ford building infotainment systems, dashboards of cars, and I just love building things. That's all I love to do. I said if I could spend my whole life doing nothing but building physical products, I'd be happy. If my mom was in the back room right now, she'd be talking about when I was 3. I come running back into the house. I say, Mommy, I fixed our car. I have a hammer in my hand. The Suburban is just dented up and down. So for my whole life, I've been building products, tearing things down, and usually not putting them back together. I'm better at taking things apart. I co-founded and started Fictive 10 years ago. Can't believe it's 10 years in September. Back in 2013 with my brother Nate. And we founded the company on really this principle of how do you build hardware at the speed of software. We're a Silicon Valley-based company. We've raised over $200 million. We've produced 20 million parts through this model that I'm going to talk to you a lot about, all around new product development. But being in Silicon Valley, it's a little different than Boston. The software folks get to have all the fun. And that kind of like irked me as a mechanical engineer. I wanted to build a tool stack for mechanical engineers, people building physical products that would allow you to build hardware at the speed of software. My own pain that I had at Ford, so I'm building dashboards, infotainment systems of cars. This is back when we were trying to do BYOD, bring your own device into a vehicle. And so what would happen is you'd have an idea, you'd whiteboard it, you'd make the spec requirements, put it into CAD, and then you wait. You just wait. We had in-house machines, tier 1, tier 2, tier 3 suppliers, local supply chain that we built, and this slow process of I have an idea, I want to build this new vehicle buck, and then I actually want to go test it and build a physical version, was this process of waiting. And so I felt that I spent all these years going to school, learning thermodynamics, learning fluids, learning materials, everything that I love doing, and I was mostly managing vendors. And I said, well, it's really sexy. I work at Ford, I get to build dashboards, all these great things, but I'm really kind of a glorified supply chain manager trying to actually get physical things made. And so we said there has to be a better way to build physical products than this old way of building and running supply chains. And so we set out on that mission of how do we build physical products at the speed of software almost 10 years ago. You fast forward to today, we work with thousands of companies, some that are in this room, ones that are giving talks. We work in robotics, we work in healthcare, we work in automotive, a lot of different industries. We have 5 global offices all over the world, really around the speed of how do we help you speed up and supercharge your development cycles. And so what I want to do today is actually talk about this problem across industries, but specifically within robotics. What are common pitfalls that we see that companies, engineers are doing that slow down their development cycle? And our belief is that slow development cycle kills innovation It means products don't get to market. It means that your time to revenue is longer. It means that they never see the light of day in the innovation. So fundamentally, we believe if we want to put, rockets that go to Mars, if we want to build surgical robots, if you want to build EVs, all the innovation we want to do, humanoids, you have to solve the infrastructure, the shovel for how you actually build product. So you all are the experts in robotics and what you do and in your deep domain. And I want to help share some tips and tricks on the manufacturing side of how you can speed up your development. And that's what we'll spend a bunch of time on today. So fundamentally, I talked a little bit about this, that we believe that slow product development is one of the killers. I like to talk about this a lot in the terms of software, because software is relatively fast today. You have a lot of tool stacks. I leverage GitHub. I have AWS. I have all these collaborative tools. I can Dockerize something. If I want to learn a new language, I can go online and do that. In hardware, that's not the case. The way that I learned when I was at Ford, I found a guy, his name was Gary. He'd been there 30 years, and he knew everything about building vehicles. So the way that I had to learn was from Gary. How many people have learned how to build robots from a Gary? Is Gary in the room right now? Okay, I'm sorry if your name's Gary. But my point being here is that if we want to unlock all the innovation that each of you is doing, we have to fix this problem around slow product development. We have to be able to go from an idea to the specifications to a physical part faster, easier, less effort. And that's what I want to talk about is what are the pitfalls? How might we do that? Fundamentally, this is what we think about what the cycle looks like, that after you have that idea, you build the CAD 3D models. Again, remember, I'm focused on the mechanical aspects today. You then go out and get a bunch of quotes. How many people's company have a 3-quote policy? Have any big ones? A few, okay. Ford was like 3 mandated. Imagine that, everything, even if I know this is a shop that's gonna do it, I have to go get 3. You then get a bunch of feedback, right? Once when you talk to a manufacturer of how this product might get made and say, hey, why don't you change this material, change this feature, change the way it's done, you go through another do loop that happens there. You then, if you're a big company, small, how am I gonna pay for it? Is it credit card, purchase order? How does this get sent? And then you wait. In my experience when I was at Ford, it was usually 6 to 8 weeks was kind of my development time that I was waiting. The way that I pushed things along, believe it or not, was a 6-pack of beer. I tried paying people more money. I tried skipping the line. I tried using my Ford email. I tried getting my boss to call him. The single thing that moved the needle for me, I'd walk down to the machinist and I'd be like, here's some Budweiser. Like, can I get this tomorrow? I kid you not. And maybe some of you had the same experience, that your relationships with your vendors are so critical because you are beholden to them. Other folks solve it by, I'm going to build my own machine shop or research lab or prototyping lab that we had there. So you have a CapEx heavy option. You have a deep partnership option. Does anybody here want to be great at managing your supply chain? Show of hands. And why? So someone shout out. Why do you want to be great at managing your supply chain? Yeah, you. Yeah. You want your parts. Anyone agree with that? So the only reason you want to be great at managing your supply chain is you want your parts. What if you could get your parts and you didn't have to be great at managing a supply chain? That sounds good too. Okay, well, let's talk a little bit about that. To help me express this idea, I want to talk about 3 different companies, all in the robotic space at different sizes. One is Gecko Robotics. Show of hands, anyone know Gecko? Do I have any Gecko folks in the room? No? Okay, so you can hold me honest. Gecko, they've raised over 100 million, several hundred people. They've built an awesome application that's all around inspecting really dangerous, say, oil tanks, gas lines, shipping containers. So we'll talk about an at-scale startup. Heavy Robotics is a smaller organization. How many folks know Heavy? A few local in the area here. So Heavy, small, lean team. I love this team. It shows what the power of like a lean team can do to produce a tremendous amount of innovation. And then we're going to talk about Honeywell as well. Big, massive organization. My big point here is that it doesn't matter the size of your company, what you're building. Am I at a research institution? Am I at a university? Am I a startup? Am I a venture funded? Am I a large corporate? If you can adopt digital tools, if you can remove some of these common pitfalls, I promise that you can accelerate your development. And so in all the talks that I give, I want to make sure that you're walking away here with actionable things to get done. That's my belief. As you spent your time to spend an hour with me here, I want to make sure you're walking away with some takeaways. So I want to go through 3 common pitfalls that we see across the board. And those 3 that we're going to talk about today of why slow is, the first one is engineering perfectionism. How many engineers are perfectionists here? Yeah, I'm looking at all of you. And the ones that didn't raise your hands, you're kidding yourself. The second is around a single source of truth. We see this kill companies. It's actually in the beginning, you kind of get by and you skate and you make it work. But as you scale and grow, and I'll show you some examples, not having a single source of truth during your development process kills you. It kills innovation, kills your time to market, and frankly kills companies. And the third common pitfall that we see a lot is legacy procurement practices. That the way that people buy things, the way that folks go from an idea to physical part hasn't changed much. And most folks, like the brave gentleman that said, I just want to get my parts, said, well, this is how we used to do it, and so we just do it this way today. No one's thinking about innovating on your supply chain to speed up development cycles. And so we'll talk through each of these. The result of this that we've seen, this is across industry, is that long lead times is what kills things. You get really, really expensive parts and you're spending more money than you don't need to. No vendor is going to tell you that you're spending too much money. Has any vendor ever told you that you're spending too much money? Probably not. Very few, unless you have great partnerships. I'm looking at you. And then the last one is that you get really difficult parts. What I see in robotics all the time is you have challenging parts. But what does a challenging part mean? When a vendor says that's impossible to make, is it impossible or is it just difficult? And all of these have outcomes that we'll talk about that slow down your development and allow you to not get to market. Your product will die on the shelf because you haven't solved these things. So let's dive into the first one first. Engineering perfectionism. I love this because we're building robots. They have to be precise. They have to be accurate. Remember your bullseye, does it hit the middle or does it scatter? Accuracy, precision. So as engineers, we are trained to build something with sub-micron of micron level precision that these robots do. But in the early days, you're applying those same sets of principles to how a part gets made in the very early days of building. The first way that I learned to build when I was at Stanford was with foam core. You want to know what my favorite prototyping tool today is? It's foam core. It's literally what my daughter uses for science fairs. I take an X-Acto knife and start cutting up, and Rose is like, Dad, you can't do that. But I love foam core because I can build a lot of things out of foam core and rubber bands. And I can prove out concepts, mechanisms, actuators with really simple tools. But what I see in engineering perfectionism is most people want to go straight to being perfect. They want to over-tolerance something. They want to over-spec it. You want to have a high safety factor on it in the early days. And so engineering perfectionism, I'll actually talk here. Samson's one of our technical application engineers. This is a great article. If you scan that QR code, we'll take you to it. And he comes from the aerospace industry. And he says from his experience, when smaller companies are trying to manufacture aircraft, they're not usually completely redesigning that technology. They're making a modification off existing technology. This idea of invention versus innovating. That if you can build upon existing foundations, you can actually accelerate development in a lot of ways. And so you have to be able to separate these two ideas of what is perfect versus what is good enough. The classic saying is that, perfect is the enemy of good, right? So what I want to talk about is this framework. This is the first takeaway that I want you to have around how might you build least effort parts. Don't build the perfect part. How might you build least effort parts? And I'm going to give you a framework that we talk about here, which is the 5 axes of manufacturing effort. So in all the parts that you're designing, I want you to go back, whether you're the engineer or not, I want you to look at these axes. I'll actually go to the next one. This will take you to the DFM masterclass. You want to go learn all about this. And there's 5 key axes to think about in every single part that's on your BOM, your bill of material. The first one we'll talk about is geometry. Is it a complex geometry? Meaning, is the effort high to produce that geometry? Think about it. Does it have 3D curves in it? Is it just a block? Is it a hole? Are there things about the geometry that are really challenging, mating surfaces, these things? The second axis to think about is tolerance. What are the tolerances needed on that part when you produce it? Do they need that tolerances? What are you trying to de-risk in that? Is the effort to achieve that tolerance high or low? The third is look and feel. We see this all the time. I build a prototype, my CEO is going to look at it, so of course I need it to be bead blasted with black anodized, I need this mil spec on it, I want you to plug all of those holes, and I want to make sure that you have this surface roughness. It's like, well, what rev is this? Well, it's our very first prototype we've made. Do you really need that look and feel of it? What is the effort to achieve that? As you go through these phases, think about the effort to achieve a look and feel. Material is another one. We know robotics, everyone wants lightweight, high strength. You want it to be durable, last cycles. Can you do it with foam core? Can you have it do 5 cycles to prove out what you need? 10 cycles? What's the duty time that you need on that? Think about the effort of that material. Cutting A2 steel tool is a lot harder than cutting 6061 aluminum. One might wear out, one might not, but there's different ways to achieve this. And then lastly is part size. Is the thing this small and it's micrometers, or is it really big and it's going to take a freight and a wooden box for this thing to ship across the country? Are you able to break that part and fasten it together in different sizes? There's different ways to look at this. So when someone says that your part is too perfect or it's really complex, I want you to think about these 5 axes. And it's a really simple. The middle of it is least effort. The outer ring is maximum effort. And I kind of gave you an idea that for this part you see on the screen, how might you draw this web diagram? This is a tool for you to bring back to your engineering team in your review meetings to say, are we designing least effort parts? Are we minimizing our engineering perfectionism to speed up development, to get to market sooner, and really de-risk our product? I'll talk about how one company did that, because I said I'd use real examples. Heavy's a great example. Small, lean team, maybe they're sub 100 people. They were having a lot of trouble when we met them with surface finish related to the part. They were waiting days to get feedback. So every time they'd send it off to the vendor, say, is this producible? Wait 24 hours, get it back. Send it back, get it back. So they were losing days and weeks just trying to get manufacturing feedback. They were losing hundreds of thousands of dollars in sales due to inventory challenges, meaning they either had to spend a whole bunch of money, tie up capital to sit on all these robotic systems, or they didn't have any robotic systems in inventory, so when sales would come in, they couldn't actually sell those actuators. So you're stuck in a hard place here. And lastly, it was months. They were literally waiting, I think, 3 to 4 months to get custom gears made. We spent a lot of time talking about gears. When they switched to a digital solution, here working with Fictive, and I'll talk about that, they were able to take their cycle times from 16 weeks down to 2 weeks. Just want you to think about that. I want you to think about if your development cycle is 4 months today to get 1 iteration out, what would happen if you moved to 2 weeks? It's math, you'd get 8 more cycles. If you had 8 more swings at the bat, would you have a better product? Show of hands, you think you'd have a better product with 8 more swings? Does any engineer want less swings at the bat to get it right? How many people here feel the pressure when you know it's 8 weeks to get something of how perfect that product had to be? How many people feel that pressure? Okay, if I said it didn't have to be perfect because you could do it 8 times, would that pressure go away? Show of hands, kind of nodding. Everyone says that. That's the result of this, is that perfect is the enemy of good, whatever that phrase was. But the idea here is think about how Heavy is adopting it. You see some of the custom gears, you see some of the housings, actuators that they're building. If they can reduce lead time by looking at different manufacturing technologies like additive, if they can look at different certification processes, they're not having to certify, but AS standards, leveraging different shops. If they're getting DFM, designed for manufacturing feedback, in a digital way versus offline email, they speed up their tolerances. This is a Pareto. You don't go from 16 weeks to 2 weeks overnight. You're chipping away at every step of the process to speed up your development process. Gear hobbing is a favorite one. I'd love to take any questions around custom gears if folks have it at the end. The second pitfall that I want to talk about here is that working without a single source of truth. Maybe just show of hands for me. How many people work on an engineering team under 10 people? How many people between 10 and 50? And how many people over 50? Okay, so kind of a mix. We have a third, a third, a third, kind of in each one. What I've seen across all the companies is this is, no matter what the size of the team, kind of what your tech stack looks like for collaboration. Google Sheets, Excel, maybe some arena in there that nobody likes but has to use. Oh, I get chuckles, that's good. Asana, SolidWorks, email, Slack. It's all of these kind of generic business tools that we use. Is this resonating? Just like nodding heads, it's like, that's your tool stack? Could you imagine if that's how our software was built today? I'm gonna throw out GitHub, I'm gonna throw out AWS and S3 buckets and all these. I'm gonna throw out, do you think we'd have the software we had today? No, I don't think so. So we are all searching for the Holy Grail. I told my team I'd give a bunch of Monty Python jokes. They said, don't do it, Dave. I'm in the middle. But the Holy Grail is what we're looking for. How can we develop a single source of truth where collaboration happens? What we see is a lot of heroics in product development. One of the largest pitfalls is when you're that team, sub 10, you're working in a research lab and new things, life is great. You swivel your chair, you're working on something, you have multiple, it's a robotic system. The chassis team can talk to drivetrain, can talk to the different actuators. But as you scale up, that single user kind of experience that you had, you're playing like Halo by yourself, and then you go to multi-team and it becomes more complicated. That becomes really, really challenging. And so the largest pitfall that we see is folks aren't looking around the corner here is what will development look like when we need to do more collaboration. That's the second biggest pitfall, is that we're not talking about that when we want to manage vendors, when we move from that 10 people to that 50 in that range, now everybody has a guy, right? Everyone has a guy that does really good parts, yeah? Mostly guys, some gals. But as we move, then you have all these vendors and your parts are all over the place, you're spending a lot of money, it becomes really challenging. We solved one aspect of this problem. It's what we call premium, where teams can work together on quotes, teams can work together in a digital way to get DFM, teams can work together to collaborate on how you configure, how you spec, how you build products. What I like to say is that we kind of built the Domino's pizza tracker, that you can track a $10 pizza easier than you can track your $1,000 parts that are being delivered to you. That's all the visibility that we built. We wanted you to be able to say, hey, I'm ordering these really complex mechanical parts. I want to collaborate as a team on the design for manufacturing feedback. I want to collaborate and optimize for price versus lead time. I want to collaborate so in my stand-up and my boss is saying, when's the parts going to show up? When's the parts going to show up? Are we going to be able to assemble on Friday? Are we going to be able to assemble on Friday? You can be like, yep, it's right here. It's past quality. It's out of export. And it's on a truck being delivered to us. That's what we've solved. Onshape does good things here. Collab does good things here. There's a lot of digital tools that allow collaboration to happen. What I see is that teams aren't adopting best practices for creating a single source of truth for your development efforts. So as you go back, I want you to think about how might we collaborate better together? How might we get our engineering teams and supply chain talking together? How might the chassis team talk to drivetrain? What tools are we using? Are we using best in class? Are we investing in that? I know everyone hates their PLM system you're using. Is it set up well? Are you using it? How's your version control? I see someone laughing here. Yeah, naming is a whole nother place we could go down. We can get into some fun topics, but I want you to think about how do you create a single source of truth to speed up product development. Again, I'll use an example here. We talked about Heavy before. Gecko Robotics was in this. Venture-backed business, raise money, I need more and more robots, scales comes up. These were the challenges in the early days when we met Gecko. They were waiting 1 to 2 weeks just to get quotes. So what would happen is they'd have an idea, they'd go get a bunch of quotes, they'd wait 2 weeks just to come back to make a decision between do I want to spend $5,000 and get it in 4 weeks, or do I want to spend $4,000 and get it in 8 weeks? So you lost 2 weeks of time to do that. They were having these issues across the board that some vendors that had good relationships were low cost, others were high cost. I knew a guy, I was managing my network, other folks weren't. It was kind of all over the board. But no one said it wasn't working, except for if you zoomed up and whoever was managing the whole team that said, this is chaos. Quality of parts was all over the place. Vendor was good for first order. Vendor was good for second order. How do you think the third order was? How do we think the fifth order was? Anyone had this experience before? Yeah, degrading, right? So the quality was all over the place. And deadlines were a result. We hear this all the time. You used to have your stand-up meeting, where's my parts? We got to do assembly. We need everything to come together. My circuit boards, my mechanicals, my wiring harness. Is the software going to be able to load on the chips? All that has to integrate well, and nobody could tell you when's the stuff arriving. And to the CEO, the guy that's running the company, I remember this back there, I'd get chewed out by my boss at Ford. He's like, what do you mean you don't know? I was like, well, he told me 4 to 8 weeks. Well, is it 4 weeks or 8 weeks? These are the challenges that Gecko is having. And so when they adopted digital solutions, really in this idea of having a single source, Fictive was part of that. We were not the full solution, but they adopted this methodology of, can we do quotes in seconds, minutes, days, in a day, not in a week or 2 weeks. We got to be able to have answers of, do I want to spend $5,000 or $3,000? Do I want it in 2 weeks or do I want it in 1 week? Make trade-off calls between time and price. They needed to get design feedback across the board. What they were seeing was that if I had design changes that happened to my chassis to optimize for least effort, they adopted that principle. What did that do to my drivetrain? Were they collaborating? Did you know the changes here in the release and the rev that you sent out? How did that affect the changes in the other aspect of it? They looked at tolerances across the board of how can they minimize that, and they were able to shave real time savings off their design cycles. What happened then is they moved from a waterfall to more of an agile-based development where you were just getting better. You get in this habit of shipping all the time because you go from waiting 16 weeks down to say 2 weeks, and you can do it 8 cycles. You stopped worrying about it having to be perfect every single time. You get in this methodology of shipping because you have a single source of truth and you can move quickly, which is a really important aspect. And I can talk a lot about Gecko. They're a phenomenal company. The third pitfall that we see all the time is legacy procurement methods. You start a company, I did, we're about 350 people running and all this. I didn't wake up one day, left Ford and be like, I want to be really good at talent acquisition. I want to run the best HR team. I'm a big culture guy. I talk a lot about culture. That's probably my second, maybe my top favorite topic. But you don't wake up and try to be great at this. The same thing is true in supply chain. I don't think there's a single person in here, a CEO, a founder, that would say, we need to be world-class in supply chain until the pandemic happened. That's what shook all the systems. You go before that, supply chain was mostly a functional issue. It was mostly something that your head of operations, your chief procurement officer, depending on the size and scale of your organization, they dealt with. Pandemic, trade war happens, pandemic happens, big conflict in Europe happens, Suez Canal, all these things that exposed all the old school legacy ways that we procure products today. What happened as a result? Supply chain went from a functional issue to a C-level issue to an owner issue to boardrooms. Now we read supply chain issues on Wall Street Journal, on Bloomberg, on New York Times, you pick your publication. Supply chain's all over the place. We've seen this pitfall over the 10 years of building the company, and still today, even with all that in your face, I'm still not seeing enough companies shifting their mindset off of legacy procurement practices. What we see a lot is webs that look like this. Folks spending a lot of time and money chasing around vendors. You have price, I have lead time, what's the status on this, what rev did you use, all of these different things. Meanwhile, you have digital systems, other ways to procure parts, and they're not even looking at a new solution. Very few folks are actually saying, I need to solve the way that I procure components. What I'm trying to advocate to you all, this pitfall that we see across the industry, is that slow product development is the function of products dying on the vine. And what's driving slow product development? It's procurement. It's legacy procurement practices. Do your 5 whys, your Toyota, solve the problem at the bottom here. Other industries have done this, so this is what I like to talk a lot about here. If we said today, or if we said 10 years ago that you would get into a stranger's car using your mobile phone and not take a taxi everywhere, it'd be a little crazy. Or that you wouldn't say, at the Marriott, you might actually stay in someone's apartment when you're here today. And it's like, that sounded crazy. We do that today. There's a lot of other industries that you're not going to own server racks, that you're going to actually outsource all your computing to like a third party to manage all that. That's cloud. There's a lot of other places that seemed really like when you were running an IT team and they had all those on-prem server racks, you want to do what? You want to put all that compute in the cloud? You want somebody else to manage that? No way you're going to get it. The same thing has to happen with procurement. We all have to look at it as engineers, a problem we have to solve to speed up development practices. I'm a little biased in this, and this is where I'll tell you what Fictive does. We believe digital manufacturing is the solution of this. We don't own a single machine. We find machines or factories that are idle, have extra capacity. We vet, onboard the supply. We put our technology in it, and then we allow all of you to order parts from those machines, from those factories. We have 250 of these partners globally that are all on our network and vetted so that you don't have to manage parts yourself. You don't have to manage the supply chain. That's what we do. We're your manufacturer of record. We allow you to say, I upload your design specs. I know that it's $5,000 to produce here in the US and I'm gonna get it in 5 days. I know that it's $3,000 to produce it in China and it's gonna take 7 days. I know that I could look at Mexico and it's a cost that's in the middle here. All of those trade-offs can be done and we're managing that supply chain for you. But we don't own a single machine. We focus on the technology and we focus on the workflow to get tight tolerance, highly complex parts to your door yesterday. And that's what I think digital manufacturing can do. The digital is not just about producing the actual part though, it's all of the online systems as well. When I was at Ford, all this DFM feedback you see, this is an injection molding analysis. I had 2 ways. I could either go to Proto Labs and I had to do all these constraints for how my part would get made, or I would go directly to a vendor, usually in Asia or different really highly skilled US manufacturers, and I was in PowerPoint, email, and WebEx. I hate WebEx to this day. Like that little ding when it chimes to me, I think it's my nightmare that I see. And it's all because it's archaic tools, it's legacy procurement practices. When you look at digital tools, and there's a lot of options here, so yes, Fictive, I'm biased, but there's a lot of different ways. What I'm trying to advocate for is that these digital tools give you online DFM feedback. You can produce 2D drawings on the fly and annotate them. You can track your products like they are a pizza, but it's $10,000 of critical items for your robot to actually be able to function. You can collaborate on them and see real-time pricing. You can order parts like you buy a ticket on Kayak rather than having to go to United and Southwest and American, all different places. Digital tools can help you adopt best practices to procuring products today. And I can tell you that back to this, I'm going to use examples for how this is done. This is not just small companies that are leveraging Fictive in these digital tools. I want to talk about Honeywell a little bit. Everyone's heard of Honeywell, show of hands? Okay, he hasn't, but that's fine. So Honeywell, their aerospace division is $16 billion. They do $6 billion in MRO, maintenance, repair, and overhaul. Engine breaks, you got to go fix that thing. In order to support all that MRO business, they have hundreds of just CNC manufacturers, hundreds in their supply chain. And so we got to doing a lot of work with Honeywell. They eventually invested in us. Their chief supply chain officer, Torsten Pils, sits on our board. And I said, Torsten, what does that cost you to the organization? He's like, it's about $40,000 to $50,000 per vendor. It's like, so you're spending how many millions of dollars just managing vendors? He's like, we have to do it because otherwise I can't deliver the $6 billion. Their challenges that they had, I'll talk about a very specific product here, which is goes on the Chinook T55 engine. It's got an auxiliary power unit, an APU, which has some commercial applications as well. They were waiting 22 weeks. I was like, weeks? That's 7 months. You don't have to do the math. 7 months to get parts back for that. So my 8 weeks at Ford is nothing compared to the 7 months. They were waiting days, usually weeks, to get quotes back and forth, and they were in cycles of years. They talked about quarters. Okay, my cycle time on this, T55 Chinook engine, it was developed in the 50s here. It typically is 6 months to get through one rev. How many people want to work on that product, right? So I'm giving you a little bit of relativeness, to here, but these are real challenges around product development. So as we got to know them, what we want to do is completely turn their procurement practices inside and out. And we moved to be able to getting all their quotes done in seconds. That's showing you the actual APU, the auxiliary power unit on the left. They're like flagship. What they raised is like, this is awesome. They were able to get design specs out in the morning and cut POs by the end of the day. For a big company, this was like huge. Just think about how much it cost. That the quote to order happened in the same day. And they were able to reduce lead times just like Heavy did, literally from 22 weeks down to 3 weeks. And I'll show you what that looks like. I love Gantt charts, gives you an idea. You do things in series versus in parallel. That's how you're able to get time savings. We're talking about sourcing requirements, DFM, quoting, purchase orders. Do I use 5-axis CNC machining versus traditional casting? Can I do additive with some subtractive to get the same type of parts? Where do my inspections happen? How long is that? What's my shipping, my tariffs? In order to do this, to do procurement, you have to go soup to nuts. And so what I'm trying to advocate for here is that large companies are doing this. They are adopting digital tools. We are a portion of that digital tool stack, and that smaller companies are doing as well, having the same results. They're taking development cycles that are taking weeks and months and moving those to days, maybe a week or two. And those are competitive advantage. So if you're not using these tools, I guarantee your competitors are. I can almost promise you that. And so these 3 major pitfalls that you have is engineering perfectionism. How do you create a single source of truth, be able to collaborate, and how are you going to change your legacy procurement practices? So my kind of question, what I want to leave you on is, do you have a plan? As you go back, I wanted you to have concrete things that you take away with you here. Develop a plan, build a digital strategy, look at your procurement practices and say, can I speed up my product development? And by speeding it up, get to market sooner. And can I actually find a way to de-risk my product? If you do that, you do supercharge your new product development. And I'd love to take questions, because I said I'd leave some time at the end and talk to all of you. Again, I'm Dave Evans. You can find me on Twitter, also at fictive.com. And thanks for listening. Yeah, please.
In the case of Honeywell that you mentioned, and I've worked at large, aerospace companies in
Yep.
the past. What specifically do you do to get the lead time, the parts order down from whatever it was, a couple of weeks or whatever it was, down to 30 seconds?
Yeah, the biggest thing that we do is that when somebody gives us both the 3D and 2D requirements, what we've built is an AI engine that's running simulations for how that part gets made. So you upload and say, if I grew this part, so I did additive, here's what it would actually cost, here's what the lead time is. If I did 3-axis machining, 5-axis machining, it's running all those different simulations and actually doing kind of like a digital twin is what it's doing. So what it's saving you is, rather than having to go out to all the vendors, gather that information, how might I build this? Maybe that's spec'd in the beginning, maybe it's not. You are cutting down all the scenario planning that you're doing in that case, and you're doing everything in parallel. So I'm giving you design for manufacturing feedback. We're looking at the optimal way to produce it. We're looking at cost, lead time differences geographically. So it's a whole variety of things. I mean, you don't go from 7 months down to 1 month with like a silver bullet. There's no such thing. Yeah, ask your follow-up.
So follow-up. So
Yep.
that gives you the should cost.
Yep.
Right, effectively the optimal way of making it and the should cost. But you still need to get the quotes from your substrate suppliers.
So that's where fictive comes in. What we're delivering is not a should cost, it's the actual price of it. Because what we know is we have 250 partners, we have pre-negotiated contracts with all of them. And so I'm saying, look, that's $5,000. When you buy it for $5,000, I know there's a machine available today that's gonna produce it for that. Just like Uber, it's not like they picked you up from Logan and said, hey, it's $50 for you to get to the conference. That's not a should cost, that's $50 that's gonna charge you. Exact same thing. But now imagine if I built fictive and I didn't do all that simulation. I didn't actually figure out how the part would be built. I couldn't give you an accurate price that I could stand behind. So it took us this 10 years, $200 million of venture technology, and 20 million parts through this engine. So I have confidence every single time Honeywell uploads, this APU product, and I can say, yeah, that's $4,000, 21 cents. So what you're seeing is not a should cost, it's an actual price. And I can run that simulation for you in Mexico, India, China, US, all in real time. Yeah, awesome question. I'll take this one here.
Specifically to your point about single source of truth, can you talk a little bit about the cost savings and the speed
Yeah.
to become compliant, improve compliance as a result of the single source of truth?
And is your question from a regulated, like an ITAR, a 1345?
I'm thinking med device as an example.
Yep.
Being able to press a button and show traceability to an FDA has
Yep.
got to be worth an awful lot. So
Yep.
having a single source of truth, you spoke to it in terms of the efficiency of the engineering effort.
Correct.
But there's got to be a huge value to that in the time it takes to get ready for compliance.
Yep.
To get through compliance and so forth.
What I found was the largest challenge is that you go to all these mom and pop shops primarily that are like producing your parts today, and they're offline analog. So like they might have traceability, but it's paper. Sometimes that paper gets scanned, then that's like going in a manila folder in some locker somewhere. And so as I was doing development, Ford was for me, so it was a bunch of automotive standards, PPAP requirements that we had. Most of my vendors weren't giving me that information. Or if I wanted that information, good luck, go tack on 2 months to getting that part that was done. So what we built from the ground up when I talked about that pizza tracker is that every single part that goes through our system, we're recording all that data log, where it gets produced, what the tolerances are, the CMM data, that's all digitized. So you could say, I'm building a product for my med device, Transmed 7's an example, they do a cardiac, an implant. And what they're able to see is that from every revision that they did, from 3D printing to soft tooling to the injection molding to 13485 certified, all the quality data, where it was produced, all of that through our system. And there's a lot of work still to be done here. Like we're not ITAR certified. We do some regulated industries, but most of it is I wanted to build the foundation to be able to do that stuff. So I don't want to blow smoke or vaporware. Like there are things we can do today, but I think there's a long roadmap ahead of what we're just getting started with. But I think that single source of truth is critical for any company, and it needs to be digital. That's my point of view, and it has to be collaborative. What I see is people create a single source of truth and it's offline, or they create it, but not everybody's using it because it's too hard or policies. So that's the pitfall that we see. And what I'm saying is like Fictive, we're solving this challenge. We've solved aspects of it, but we have work to do as well. Yeah, thanks for the question. Yeah.
Dave, as an entrepreneur, I have to say that this is a great business model and a great business, great idea. But I was very much wondering about the business model, how you charge it.
Yep.
Is it SaaS or you sell the parts or is it just
Yeah, great.
commissions you cut?
Yeah, it's transactional. So we're taking a cut of every single part, just like a Uber does, that you're not paying for it. What we learned was that folks in the space don't really know how to pay for software. So the only software you pay for is we have what's called a membership to be a part of Premium. And so it's saying if you want collaboration, some enhanced features here, you pay kind of like you would Amazon Prime to get 2-day shipping and these things. So there's upgrades like that, but it's not a SaaS model. It's a all-in fee. So this $5,000 we're talking about here, that's a fully baked price. You can see all of it. And we wanted kind of what you see is what you get business model. And that's worked out really well for us because we can provide best cost to a customer. And it's like $5,000, that's the best thing, that's good for you. And it's like, and we're making our business, we've scaled. So obviously it's working well. And I think we're saving a lot of money for customers due to the cycle time reduction and also due just to the global footprint that we have as well. Yeah, that's great.
Thanks for giving me PTSD for that WebEx sound I'm looking at. One question I have is sort of as you go through the product cycle, so I love on chips as a single source of truth, but as you go through the product development cycle, you have the first X many units where you print X many units soft tool, then hard tool. Do you have any tools in terms of modeling that across and when there are ideal transition points through the process?
Yeah, I would say most of that happens with, let me back up a second. I believe that the best type of automation is human plus machine. Like my point of view as a technologist and as an entrepreneur is don't try to build lights out full automation. I think that manufacturing is too complex. The products you all are making is like lights out is really challenging. So when we went to solve the problem that you're talking about is what are these cutover points of like, grow it, so additive, soft tool, hard tool. We've built a lot of tools that helps the analysis, but we leverage Samson, our technical application engineers, to do those conversations with you. So rather than say like, here's this full simulation tool, drop it in like an Onshape that you're not talking to them about how you might use it. Maybe you look at the community forum or these things. we believe in a human in the loop, and so it's a pretty collaborative exercise. So the engagement looks like you upload your model, you can see some price, some simulations of doing all these, and then you'd engage with our customer team and say, hey, I want to sit down and talk about the trade-offs. What are my cutover points on volume or lead time? And we've found that I think we're one of the most customer-obsessed companies in manufacturing. Like most manufacturers don't have the time of day to obsess about their customers. We obsess about our customers. We celebrate their launches. We do all of that, and I think it's because we get to be a part of that process. So, but yeah, does that help answer your question? Awesome, thank you. Cool. Any others? Was this helpful for folks? Cool. Awesome. Well, thanks for the time, everyone. Come up here. Happy to chat with you, and happy building. Good luck. Thanks.